In this video, we're going to look at three more properties that we can use to simplify expressions containing exponents. We start with the product of powers property, which says that for any real number a such that a doesn't equal 0, then a to the m times a to the n is equal to a to the m plus n. Let's take a look at why this one works the way that it does. Suppose I decide I want to multiply x to the third times x to the second. Now I could do this longhand way by thinking x to the third is x times x times x, and x to the second is x times x. I'm multiplying all of those together, and when I do that using the exponents, we know that x times x times x times x times x, there's 5 x's, so that's x to the fifth. Notice all we needed to do in order to simplify that was we needed to take this exponent and this exponent, add them together. 3 plus 2 gives us 5. And that's why the product of powers property works the way that it does. So let's go ahead and bust through a few examples here. X to the fifth times x to the third. We leave the base the same, and we add the exponents. 5 plus 3 gives us 8. That's x to the 8th. Part B, y to the fourth times y to the negative 2. Again, we add the exponents. 4 plus negative 2 is positive 2, and so this simplifies to be y to the second. And then part C, we've got z to the fourth times z to the negative 7th. We add those together. 4 plus negative 7 gives us negative 3. That's z to the negative 3, which we should know from before is 1 over z to the third. All right, and that's how the product of powers property works. The base stays the same, and all we do is add the exponents. Next, the quotient of powers property. For any real number a such that a doesn't equal 0, a to the m over a to the n is equal to a to the m minus n. All right. Why does this property work the way that it does? Well, suppose I've got x to the fifth over x to the third. Again, I'm going to go to the idea of longhand what these exponents mean. X to the fifth means x times x times x times x times x. And x to the third means x times x times x. And now when I have a fraction like this, I can cancel out any common factors from the numerator and the denominator. So I can cancel out a pair of x's, another pair of x's, another pair of x's. And I'm left with no x's in the denominator, and I've got 2 x's left in the numerator, so this is equal to x squared. And so our property tells us all we need to do is take these 2 exponents and subtract them. 5 minus 3 indeed gives us 2 for our exponent. And so we've got, in our first example here, x to the sixth over x to the second. So we leave the base the same, and we subtract the exponents. 6 minus 2 gives us 4. So that simplifies to x to the fourth. Part B, y to the third over y to the fifth. That's y to the 3 minus 5. We always subtract numerator's exponent minus denominator's exponent. And y to the negative 2 gives us 1 over y squared. We'll do the same in part C, z to the negative 2 over z to the fourth. So we've got z to the negative 2 minus 4 gives us negative 6. And so since we have the negative exponent, we're going to drop that into the denominator and make it positive. Now I mentioned when we're applying this property, we always take the exponent in the numerator minus the exponent in the denominator. A little shortcut that you can kind of use is if you have a bigger power in the denominator, you can subtract, bigger exponent minus smaller exponent, and then just think about leaving the value wherever the bigger exponent was. So I could have thought about doing part B here. I could have said, oh, okay, Well, I can just go ahead and take 5 minus 3, and that gives me 2. And since the bigger power was in the denominator, that's where the result is going to go. And that's another way that I could have gotten to 1 over y squared. Same thing here in C. The bigger power is in the denominator. I could go ahead and take the exponent from the denominator minus the numerator. 4 minus negative 2 gives us 6. Since the bigger power was in the denominator, the final value stays in the denominator. We get 1 over z to the 6th. This is a different way of thinking about that. If that's helpful to you, go ahead and use it. And our third property for today, the power of a power property. For any real number a such that a doesn't equal 0, the quantity a to the m raised to the n is equal to a to the m times n. Why does this work? Well, if you think about it, suppose I have x to the second raised to the third. If we think about what that means, we're taking what's inside the parentheses here, x to the second, and we're multiplying it times itself 3 times. So we've got x to the second times x to the second times x to the second. And then we can combine these, x to the second times x to the second, using the property we learned earlier. It becomes x to the fourth. And then I've got x to the fourth times x squared. And I do the same thing. I go ahead and I multiply those out. And so I add the exponents. And that gives me an x to the sixth. And you'll notice, again, all we need to do is take those two exponents, multiply them together. 2 times 3 gives us the 6. That ends up being our power. And that's why the power of a power property works. All right, so let's do part A. X to the fourth raised to the third. I multiply the exponents. 4 times 3 gives me 12. So this is x to the 12th. Then part B. X to the negative 2 raised to the fifth. I multiply the exponents together. Negative 2 times 5 gives me negative 10. And so I've got x to the negative 10, which I can further simplify to 1 over x to the 10. And then part C, x to the negative 2 raised to the negative 3. I multiply those powers together. Negative 2 times negative 3 gives me positive 6. And so this is going to work out to be x to the 6th. All right, that concludes our second video on exponent properties. See you next time.